Good morning. So we are going to learn about op-amp differentiator circuit. So what op-amp differentiator will do? It is going to differentiate the given input signal. So output is a differentiation of given input signal. Now output is V in. So my expected output is V out is equals to dV in by dt. So we are going to prove that one. The current flowing through this capacitor, I am calling it as an I1. The current flowing through this feedback resistor, I am calling it as an IF. So it is, let us assume this one is a node, VA node. So this is another inverting, non-inverting terminal, another input terminal of op-amp, that is non-inverting terminal is grounded. So the voltage is become zero. Automatically VA value will become zero because of virtual ground concept. If you don't know the virtual ground concept, please go back through my videos and watch that virtual ground concept video. Now you see this is grounded, so automatically this value is ground. I'm going to write the current KCL equation for this particular circuit. KCL is equal KCL equation. So I1 is equals to IF. According to the Kirchhoff current law, the total current entering into this node is equals to I1 and leaving from this node is IF. So now I'm going to write the equation for I1. So the current through the capacitor. What is the current through the capacitor? Actually, the current through the capacitor is dV naught by dt. So dVc by dt, voltage across the capacitor. So now I am writing the current through the capacitor, that equals to C into d by dt of what is the potential here? V in minus VA. So I am writing this one as V in minus VA. So as we know that VA value is 0, this VA value is 0, this is 0. I'm going to substitute in next equation. So what is my IF? IF is IF equals to VA minus V out by RF. So VA minus V out, I'm shortly writing it as V naught by RF. Now if you see here, this VA value is 0. I will substitute this VA value as 0 here. So now this entire equation will become as dV in by dV in by dt equals to minus V naught by RF. RF is the feedback resistance. Now I am going to write the equation for V naught, output voltage. So output voltage V naught equals to minus of RF into C, R suffix F, this one is RF into C dV in by dt. This is a output voltage expression for differentiator, op-amp differentiator. This one only I proved, op-amp differentiator. This is our output voltage expression.